Hi everyone, this is example 21 on rotated vessels, and I find it very challenging. So here we go. A closed cube 300 mm on an edge has a small opening at the center of its top. When it is filled with water and rotated about the vertical axis through its center at omega radians per second, find the force on a side due to water in terms of omega. Use specific weight of water 9,806 newtons per cubic meter and the pull of gravity 9.826 meters per second square. So to help analyze the situation, let's draw the cube. Take note there is a small opening at the center, so therefore the vortex of the imaginary paraboloid will form at the center. But we are talking here about the side, one side of the cube. So therefore, the distance from the center to the center edge is 0.15, half of 0.3, and the distance of the center from the corner is 0.15 square root of 2. So they have different radii. Therefore, the projection of the parabolic surface will be this yellow parabolic surface here. And force is gamma barred H area. So let's concentrate on this imaginary parabolic surface, this yellow one on the side. And let's draw the figure. This is the center of gravity of the area. And this is the parabolic surface. So I'll call this site H sub CE at the corner edge and H sub C at the corner. So since H is omega square R square over 2G, so for the center edge, H sub CE radius is 0.15, omega square times 0.15 quantity square over 2 times 9.826. So that would be 45 omega square over 39,224. Then at the corner, the radius is 0.15 square root of 2. So H sub C is omega square quantity 0.15 square root of 2 square over 2 times 9.826. And that is 45 omega square over 19,612, which is times 2 of H sub CE. So force is specific weight of water barred H times area, where barred H is from the figure 0.15 plus H sub CE. So this is the average imaginary water surface of zero pressure, and that location is equal to H sub CE plus this distance. And since this is a parabola, therefore the location of the center of the parabola is 3/5 of its height from the vertex. The height of this parabolic surface is equal to H sub C minus H sub CE. Therefore, this is 3/5 of quantity H sub C minus H sub CE. Barred H therefore is 0.15 plus H sub CE plus 3/5 of quantity H sub C minus H sub CE. So barred H is 0.15 plus H sub CE plus 3/5 of H sub C minus H sub CE. So combining these like terms here, barred H is 0.15 plus 9 omega square over 4903. Then substitute into the formula force on the side, specific weight of water, barred H area, where area is 0.3 square, 0.3 by 0.3. So 9806 times 0.15 plus 9 omega square over 4903 times 0.3 square in newtons. So factor out 0.15 to make this one. So 9810, 0.15, 0.3 square, quantity 1 plus 9 omega square over 4903 times 0.15, because there's no 0.15 here. And we factored out 0.15. So computing, this is now the answer. 132.381 quantity 1 plus 60 omega square over 4903, which is also 132.381 quantity 1 plus 0.01224 omega square. And if omega is in radians per second, the answer there is in newtons. So that's it for this problem.